Okay, so let's go and get on to complex zeros of polynomials. So in the kind of warm-up, what we're going to do is just kind of work back exactly what we did for irrational zeros, and we're just going to solve, some equations using some of the processes that we have used before. So in this first example, I have y equals x squared plus 4. And, we could look into factoring this as we did before, but as you notice, like factoring, this is not a difference of two squares. So the factoring method, as it was kind of difficult to factor across irrational numbers, it's going to be kind of difficult to factor across complex numbers. And again, if complex numbers is a new term for you, then I'll get to explain that in a second. So let's just kind of go with something we know. Well, if we're trying to find the zeros, we know then that we want to go ahead and set our y equal to 0. So we have x squared plus 4 equal to 0, right? We're trying to find the values of x that are make f of x equal to 0, or y in this case equal to 0. So rather than having to factor, I can solve this using the square root method. So to do that, I am just going to subtract a 4 on each side, and then I'll have negative 4 equals x squared. So now, to use the square root property, I'll just take the square root of both sides, and then you come into a problem in our real number system. And in our real number system, we cannot take the square root of a negative number. That's why we go to rely on our complex number system. So I'm just going to kind of leave it as here. I'm assuming that you've at least had some introduction with complex numbers. I will review them here after this warm-up. So just remember, we can reduce the negative, treat this as like a -1. So we could break this up into... So first of all, we've got to make sure we include the plus or minus. So we say x equals plus or minus. Now I can break this out into -1 times 4. All right? And I can take the square root of a -1. That's what we call our imaginary unit, which is going to be I. And then I can take the square root of 4, which is going to be 2. So I end up with answer with be 2i. Okay? And again, we'll get into more of that throughout the lesson. But that's something we want to see what you guys can remember from complex numbers. Now, in the next equation, we see that, all right, well, let's try to see if we can factor this. What two numbers multiply to give me 3, add to give me 3? Well, 3 times 1 are the only two factors for 3, and it doesn't matter how you add them, both positive or both negative, you're not going to get to 3. So then we look into using the quadratic formula. And just to remember, quadratic formula is in our standard form, bx plus c. So that's the standard form. So the quadratic formula, the solutions are going to be x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. So all we're going to do is collect the a, b, and c from our standard form equation and then plug it into our quadratic formula to find our solution. So we can say that a in this case is 1. So when I go and plug that in there, I get x equals opposite of b, so that's going to be a -3 plus or minus the square root of 3 squared minus 4 times 1 times c, and that's going to be all over 2 times a. Okay, and now it just kind of comes into a simplifying form. So let's simplify under our radicand here. So 3 squared is going to be 9, and then it's going to be -4 times 3. So that'd be a 9 minus 12 all over 2. And then 9 minus 12 is going to be a -3, which again, we get to that point where we can't take the square root of, a negative number. So that's why we have to now go back and rely on our complex number system. Okay, and just like we could break apart -4 into -1 times 4, we can break apart -3 to -1 times 3. However, here we could take the square root of 4. We can't take the square root of 3. So there's a couple different ways we can write our answer. We could write it in our general term of plus or minus I square root of 3, which that is the square root of -1 divided by 2. Or we could also distribute that 2 to both of those terms. Sorry about that. Then you could do -3 divided by 2 plus or minus I square root of 3 over 2. Okay? So that just is, again, a quick little reminder of your complex numbers. So a couple things to really kind of remember is when we're solving, so far we've talked about solving with real numbers, rational numbers. And then we talked about real irrational numbers, that those like the square root of, 3, that's an irrational number. And we talked about them having their conjugates. Well, in the exact same way, we can use the complex number system is also going to help because you guys can see this is a polynomial. We know that there's going to be zeros. There has to be at least 2 zeros that exist. The difference with these zeros is they are complex or imaginary. They're not actually going to be real x-intercepts of the graph. So that's really kind of the difference in what we're going to be investigating, today. And really the major idea that is kind of coming full circle now with this lesson is going to be the fundamental theorem of algebra. And just the name fundamental theorem of algebra, you can probably guess that it's a pretty big deal. So the
bring your stuff. Excuse me.
Oh, okay.
You're good to go. Okay, I think I grabbed everything. I gotta pick up my kids, so that's why.
Oh, no worries. It's all good.
Have a good one.
All right. Adios. You're all good? You're good with your questions? Okay. All right. I guess we can. That's what editing software is for, anyways. All right. So now we'll get on to that fundamental theorem. So again, the fundamental theorem, and I don't really want to read to you, but I think it's really important. The fundamental function of a degree, a polynomial function of a degree n, will have n zeros, including complex and real. Some of those zeros may be repeated. And this is very important because when we looked at, like, for instance, y equals x squared, minus 2, like that graph was kind of nice. We're like, oh, like it has 2 zeros, right? It has 2 x-intercepts. Cool. But then we also looked at, well, what about y equals, x squared? Well, the difference with this one is y equals x squared. Oh, let me write over here. Y equals x squared. That has only 1 0. It only crosses at x equals 0, but it bounces, right? So what that means is you have a 0 at x equals 0, but you have a multiplicity of 2. So that means the 0 is repeated. So again, it still goes into it still satisfies the fundamental theorem of algebra. And then we get to the last example. Well, rather than minus, what if I did, y equals x squared? I don't know why I did 2. Why don't we do plus 4 and then do minus 4? That'd make a little bit more sense. Let's do it by plus 4. Because then you can see that's negative 2 and that's positive 2, right? The negative and the positive, negative and positive 0. Well, x squared plus 4, looks something like that. And you can see there's no real zeros there, right? But you can see when we solved, we couldn't find the x-intercepts in the real number system because the graph doesn't cross the x-axis in the real number system. However, by solving using the complex number system, what we were able to do is we were able to identify a positive and a negative complex number. And those are going to be your zeros. So that is how our fundamental theorem of algebra is helpful. It tells us, whatever that degree is, whatever the degree of that polynomial, that's how many zeros we're going to have. They can be real or they can be complex, but they're always going to equal that number. And we'll learn later in this lesson how we can identify exactly what those zeros are. And so now let's just kind of do a quick little review of complex numbers. So imagine, we talked about the imaginary unit I, and imaginary unit I basically comes from the square root of -1. And I kind of represented this, a little bit going, if you're going to take I and you're going to multiply, I on both sides, let's just do it another row. So let's say I multiply I on the left and the right-hand side. Then I have I times the square root of -1. Well, this turns into I squared. Well, I is really square root of -1 times the square root of -1, which square root of -1 times square root of -1 is just going to equal -1. That's why I wrote I squared is equal to -1. And then if you do it again, if you multiply by I like a third time, so you do I cubed, well, that's basically going to be I squared times I. Well, I squared we just said was -1 times I, which equals -I. And that's how we got I cubed is -I, which my notes are wrong. Good thing I checked that. And then so I to the fourth, that looks bad. I to the fourth is basically I squared times I squared. So that's -1 times -1, which equals +1. Got that one right. Good. And what you'll notice is after the I to the fourth, it keeps on repeating. So it's not something that we're going to investigate really much further into in this lesson, but if you're a study of complex numbers, you see that that just starts to repeat along in that pattern. And really the main important thing when you're looking at, so this is our imaginary numbers, and a lot of times we'll use, or people speak of imaginary numbers and complex numbers interchangeably, but really the kind of difference is the imaginary number you can think of is really mostly talking about the imaginary unit, whereas our complex number includes real numbers a and b, and well as your imaginary unit I. So that is going to be our complex number, where a and b are actually going to be represented by real numbers. So it's still a complex number, but you have real number components within it. And the only other thing I really want to mention with the complex number is, as we noticed, as you noticed, to solve for the complex number, I had to take the square root. And when you introduce the square root, you have to include plus or minus. So what that's important is when we talk about I, or at least in an example, especially like in a polynomial, in the zeros, we always have that complex conjugate is going to exist. So if we have positive I, then we're going to have negative I as our complex conjugate, we like to say. So that's basically kind of like our understanding of our complex numbers. Now we're going to, or complex numbers and fundamental theorem. Now what we're going to do is the exact same thing we've done before for our real rational and real irrational, and we're just going to practice factoring to find the zeros. So let's go ahead and get right into that.